going to be very easy, and then they get a little more complicated. So the first rule that we're going to learn about is about central angles. And some of these we already had on the definitions, but we're going to write them down again just to make sure that we're on top of it here. If my writing thing will show up. Okay, there we go. All right, so here, a central angle is an angle with its vertex at the center of the circle, and that should make sense. It's kind of in its name, right? So the sum of the central angles of a circle is, so if I added all of the angle, like if I went all the way around the circle, how many degrees do I have in a circle? 360, right? So the sum of the central angles is 360 degrees. So this could be split into a bunch of angles, and if I added all of them together, it would equal 360. You should probably be familiar with a circle having 360 degrees, hopefully. Okay. The degree of the arc formed by the central angle is equal to the measure of that angle. Okay. So whenever we are talking about this, if we want to know the measure of an angle, they put this little M right there in front of the angle to show that you're looking for the measure. And the measure, for example, of AQB here, this angle right here, is 60 degrees. So therefore, the measure of arc AB would also be 60 degrees. Okay. So arcs can be measured two ways, right? They can be measured with a degree, and they can be measured with a length, right? Right now, we are just talking about the measure of arc. So you may even want to write this down, measure of an arc. That would look like this, MAC. That would be measure of an arc. That is measured in degrees or radians, but we won't learn about that till Unit 7. So right now, degrees is all you're going to see. Arc length, that would be measured in measures of length. So that would be inches, feet, meters, etc. there. That would be measured in measures of length. So right now, what we're looking at is right here, measures of arc. We're talking about the degrees of the arc there. So if we know a central angle, the measure of that arc is just equal to it. So this also means that if we have the sum of the central angles equals 360, then the sum of the arcs has to equal 360 as well, since they're equal to each other, right? So the sum of the degrees of the arcs of a circle is equal to 360. For example, if measure of angle AQB is 60 degrees, like it is marked here, what is the measure of arc ACB? Now, when we see ACB, we go in that order. A to C to B. So we're talking about not this little arc from A to B, but the rest of the circle. It'd be 300, right? We just subtract that from 360. Okay, so let's look at some examples that you might see. And this is a little fuzzy. I apologize for that. Some of these I remade the examples because they were fuzzy, but I don't have time to do them all. So, in this first picture, we have just one angle that is marked. It is 21 degrees right here. JNK is 21 degrees. They ask us for a measure of arc JK. William, what would that be? What? 21. Perfect. 21 degrees. They're asking for this arc right here. And the arc has the same degree measure as its central angle. That's the central angle. N is the center of that circle. Okay, now, we got to figure out some other angles or we're not going to be able to answer anything else, right? So, who can tell me the measure of another angle that would be on here? Anissa? ML would be the arc right here. If I want to name that angle right there, how would I name it? MNL. What should its measure be right there? That is also 21. Does anybody remember what those are called? Those two angles. How do we know 21 is that top angle and that bottom angle? They have a name. They are congruent. That's a good word to use. Not perpendicular. Starts with a V. Not vertex. No. Those are called vertical angles. They are, whenever you have two lines that cross, it's going to create pairs of vertical angles. So, I know that if this angle right here is 21, this is 21. Could I say that down here? Like, this angle right here, is it equal to this angle right here? No, because they're not straight lines crossing, all right? But these are two straight lines crossing, so the angles that are opposite each other have to be equal to each other. So that is very good. So is M and L over here? No, it's not, is it? Doesn't ask us about that. So what do you guys think? How can we find these other angles? Because I need those. Okay, how'd you get that? Okay, so I know that those have to add up to 360 degrees, right? So I know this one's 21 and this one's 21. So if I add those together, that gives me the 42 right here. And then it's like one of these alone is not 318. That'd be almost a whole circle. But these two together are 318. So if I divide that by 2, what'd you say we get? 159? 159. So that's the measure of this angle here and this angle here. So it says angle JNM. JNM is this angle right here. So that would be 159 degrees. Arc KL is going to have the same measure as its central angle, which would also be 159 degrees. We've got arc JKM. Oh, what's that going to be? I'm going to find that. Let me mark that in blue right here. JKM. JKM. That's all the way around here. What would that be? It's bigger than 180. I would have to add together, this part right here is 21. This is 159. And this part right here is 21. And what'd you get? 201? And then we have MKL. So MKL. We'll mark this in yellow right here. MKL. You got to go in order. So from M around to K, back around to L. It's the whole circle except ML, right? So we could add all those together, or we could do 360 minus 21, and we get 3. Oh, let's go back to blue. 320. 39. 339. One other trick, Marley, whenever you were looking for that angle being 159, Another trick you can use for this, so you don't have to do the whole thing, if you've got a diameter like we have right here, right, then a straight line, how many degrees are in a straight line? Like from here around to here. How many degrees is that? It's half of a circle, 180. So that's 180 degrees. So you also could just do, for this one right here, instead of doing it the way you did, which is perfectly fine, it works, you could also do 180 minus the 21, and that would give you 159 as well. So you could just look at half of the circle if you want, if you have a diameter. Okay, let's look at number 2. They give us they give us an arc right here is 72. And they give us this right here is 87. So there's a couple that are very easy to do. This angle right here would be 72 degrees. This arc right here would be 87 degrees, right? Because our central angles just match. Okay, then the first thing they ask us for is UXV. UXV. Oh, gosh. That's not that easy to find. Let's go down and do ST first. ST, right here. We've got to figure out what that is. Any ideas? Or how we could find it? 180 minus 87 minus 72. Because what we're looking at here, if I go from here all the way to over here, that's the diameter of a circle, right? So that's half of our circle. That has to add up to 180. This whole thing right here has to be 180 degrees. So since you already have 2 of those pieces, you could just subtract them from 180. What do we get whenever we do that, William? 21? So this angle right here is 21 degrees, meaning that the arc would be also 21 degrees. All right, let's go back to UXV now. UXV is this angle right here. Yeah, it's 72. Actually, it's an easier one than I thought, because those are straight lines, right? So it is easier than I thought. That's 72. Or I was looking at it like they weren't straight lines, because where you got those extra lines in there, it makes it look kind of crooked. But these are straight lines right here crossing. So if that's 72, this is also 72. So that would be fine. You also could do 180 minus 21 minus 87. If they weren't straight lines, you could do that, but you don't need to here. All right, so then I've got WV. What's this piece right here, WV? What's that going to be? All right, how'd you get it? All right, 180 minus 72 will give you 108. That will work. So you could take, because that's a diameter right there, 180 minus that 72. That works beautifully. Marley said she did 21 plus 87 because of those straight lines, this right here has to be equal to those 2 angles together. So that is another way that you could do it. Both of those will work. Now it should be fairly easy to get from here. We've got TW. So TW would be 72 plus 21, which will give us 93. And then TVW. So for TVW, we'd be going all the way around the circle here. And I'm hearing 267. How'd you get that? 360 minus that 93 we just found would be good. You also could add 87, 72, and 108. That'll give you the same thing. So you see there'll be a lot of options for how you get some of these answers. Okay, what questions do you have? Yes. So, for this section right here, what I was doing was looking, right here is a diameter that goes all the way across, right? So, that means, since that is a diameter, please be quiet, Anissa, this has to be 180 degrees right here, all right? So, because we already knew this was 72 and this was 87, those three right there add up to be 180. So, we could do 180 minus the 72 minus the 87. And that gave us that little piece right there. Yep. Okay. All right. Questions? All right. Let's look at a different type of angle. Actually, no. This is two more examples. I forgot these were here. We may just do one of these so we don't run out of time. All right. So, let's look at, I'm going to skip 3. Let's look at 4. Okay. Actually, let's set up, we'll set up 3. We'll actually solve 4. So 3. I've got 9x plus 15 is my degree of my angle. This angle right here is 66. That means this angle, this arc is 66. That means this angle would also be 66. What could I set up for this to be able to find x? 9x plus 15. All right, does it look like those are the same? No. Okay, that's one way we could do it. We could do 180 minus 66, and that is going to give us 114. So that has to be this arc, so this would have to be equal to 114, and then you'd solve that there. The way I was thinking of doing it was saying 9x plus 15 plus 66 equals 180, which will do the same thing there. It'll get you the same answer, but this works perfectly as well. All right, let's look over here at 4. All right, you would finish solving that, but I'm just trying to rush through so we don't run out of time. All right, for 4, what could we do there? You want to be looking for straight lines here.
180 minus 34. Well, 26.
180 minus 134, and then you put the whatever that is on the other side of it.
Okay? So there's several ways you could go about this, actually, because I wasn't thinking that way either. But if we do 134 subtracted from 180, then what do we get there? 46? No, 46. All right, so that angle's 46. That means this is also 46. All right.
And then you set that equal to the 9x plus 10.
No.
Nope.
All right, where'd you get 91? Okay, so this 46, like this is a straight line right here. And 46 and 43 together would give you 89. So if you do 180 minus 89, that'd give you 91. Here's another option for you. This angle right here is 134. It is vertical with these angles right here, so you could do 134 minus 43. That would work. There's several things you could do there. But this angle right here is 91, so you're going to say 9x plus 10 equals 91. Let's go ahead and solve this one. Subtract 10. 9x equals 81. Divide by that 9. X is going to equal 9 for this. Okay. there are a lot of ways that you can get to that 91 right there. For that. All right, let's look at our next type of angle we have to know. All right, the next type of angle that we're going to learn is an inscribed angle. Okay, an inscribed angle, oh, I didn't make these, those were supposed to be not there, so you had to fill in the blanks, but there they are. All right, so inscribed angle is an angle with its vertex on the circle with two sides that are inside the circle. So your points of your angle are all going to be on the circle. The vertex is not in the middle like it was, it's over here on the edge. So the intercepted arc is the arc that lies between the endpoints of the inscribed angle. So for angle ABC, the intercepted arc would be AC here. So this is what you need to know for this. The degree of the inscribed angle is half the measure of its arc. So for example, if this arc was 100 degrees right here, which I'm just making up, it looks close to me. If that was 100 degrees, then this angle right here would be 50 degrees. So whenever the side of the angle is on the circle, not in the middle of the circle, but on the circle, is going to be half of this measure of your arc. Okay there? All right. So here are a few examples that we will have. If I know this angle right here is 57, I've got my question mark over here. What would I do to find it? 57 times 2, which is going to give us 114 right there. Okay? 6 says to find the measure of QS. So QS is an arc, and it's the shortest distance from Q to S, which would be this left side over here. And we don't have any central angles for this. Like we don't have the angles that go to the middle, which are easier to find. So what we need to do is we need to find the endpoints right here and look at the angle that goes with that, which would be this angle, right? So this would be our inscribed angle. QS is our arc on the outside. What is the measure? How are we going to find that measure of QS? We just multiply 79 times 2, and that is going to give us, what? 158. So 158 degrees there. It's really just like this one over here, but those other lines can sort of throw you off on this sometimes. Okay? I think we got a couple more to do for these. All right, so here we have, this angle is 45. That's just for this arc over here. But this 45 does not tell me what this arc right here is. 45 tells me what KL is. What would the measure of KL be? 90, because we would just double our 45. Okay? So what is the measure of JK over here? It is also going to be 90. Is it just because those are always equal to each other? It is not. This is half of a circle right here. That is a diameter. So that means this whole thing is 180 degrees. So if we do 180 minus 90, we will get 90. So they are congruent to each other in this problem. They would not always be. If that had been anything besides 45, then we'd do 180 minus whatever we got, and we would not get the same number right there. Everybody okay there? Okay, so this one gives us this angle, but then it asks me for this arc over here. Now, this angle does not go with the arc that they asked me for. This angle goes with arc KF. What could I get for my measure of KF? 104. We just double that angle. So, it asked me for FM. What should I do to find FM? $180 minus 104 is going to give me 76. That would be my arc FM. And I can do that because those two right there, there's half a circle that has to add up to 180 degrees for that. Okay, questions? All right, here is one with an X in it. All right, so I've got that this is 10x plus 1, this is 10x minus 11, and I've got 4x plus 3 here as this angle right here. And I've got to find, it doesn't say, I should find x, so that's what it's wanting. So, I know that all of the arcs have to add up to 360. Do I have all of the arcs right now? I do not, but I've got this piece, and this piece, they've already told me the arcs, right? I need to know what this arc right here would be. What would I do to find that arc? I'm not going to get a number answer for this. I would have to double the inscribed angle, right? So I'd have to do 2 times 4x plus 3. Which, if I wanted to go ahead and distribute here, that would be 8x plus 6 there. So that's this. But the question, I should have written here, find x. It wants you to find x. So I know all 3 of my arcs have to add up to 360 degrees here. So what I can do for that is I can say 10x plus 1 plus 10x minus 11 plus this one we just found, 8x plus 6. All of those added together has to equal 360 degrees. So, passion for this one, we are going to solve that equation right there. So what would we do first to solve that equation? We can't put 8x and 6 together because the 6 does not have an x. Let's combine our like terms. So I've got 10x, 10x, and 8x. Those can be put together. That's going to give me 28x. I also have 1, negative 11, and 6. And that is going to give me negative 4. And this is going to be equal to 360. So I wrote that kind of far away from the equal sign there. But what would I do now, Passion, to solve that? What? We're not going to subtract, but we're going to add. So we'll get 28x equals 364. And then we will divide. And you're saying that's 7. Is that right? 13? 13. For that. Okay. Questions? Okay, I said there's tons of rules here. So let's look at a different kind of rule. So another rule that you have, those first two that we looked at are the main two you need to know. If you don't know anything else, you need to know how to deal with central angles and inscribed angles. This other stuff you are going to see, you're not going to see it as much as we'll see that first stuff. So if two secants or chords, the blank right here should say intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intersected arcs. This is going to be the average of the two intersected arcs. So, for number 9, we do not have a central angle or an inscribed angle. The vertex of this angle right here is just floating around somewhere out there in the middle of the circle. It's not on the circle. It's not in the middle of the circle. It's just right here. So what's going to happen if we take the lines that make up that angle? We're going to get two arcs here. We will get this one up here is 88, and we get this arc right here is 66. Okay? Those two are our intercepted arcs. So when it says intercepted arcs, it is talking about the 66 and the 88, the two angles. Because we know that this, I could have put that question mark on top or bottom there. Those two angles right there are equal to each other. So what we can do for this is we can find the average of those two numbers. Okay? So if I do 88 plus 66 and divide that by 2, or find half of it, right? Is that 77? Seems like it should be. 77 degrees will be my answer. Okay. 10 is very similar, but here you've got your two lines right here. It's asking for this angle right here, but I don't know either one of those arcs right there. However, they do give me 64 and 118. They do give me these two arcs. So I could find this angle right here. That is going to help me find my other angles. So let's do that. We would do 118 plus 64 divided by 2. So to find the average, you just add together, divide by 2. And what do we get? 91. So this angle right here is 91 degrees. That would mean this angle right here is also 91 degrees. How could we find the question mark angle over there? Okay, we do technically the other way around, 180 minus 91, because we get a negative the other way, but that'll give us 89, right? And that will be that angle that we're looking for right there. Because you could look like right here or right here, those two, 91 and 89 there, are going to have to make a straight line to which subtract from 180. Okay? So we got central angles are our easiest. They're just the same. We've got inscribed angles where the point is on the outside. They are half of whatever your arc is. Interior intersections, we've got an average. You're starting to see, like, we got a lot of things to remember here. We probably won't have time today, but we're going to do note cards tomorrow to make sure we've got this all down. All right, we got some more. Okay, now, the big thing you need to know for this are the first two that we went over, central angles and inscribed angles. This last stuff, I want you to know it. I'm not going to give you very complicated questions with it. They'll be fairly straightforward. All right, so This is a secant-tangent intersection. If a secant and a tangent, so the secant is your CD, CB here. Tangent is this line that just barely kisses the circle, right? This is secant. Actually, it's a chord, but we can call it secant. This is a tangent. If they intersect at the point of tangency, that point of tangency is B right there, then the measure of each angle formed is equal to half the measure of its intercepted arc. This is almost like an inscribed angle. Your point is on the edge right here for that. So it's like an inscribed angle. It just looks a little different because you don't have a second end point on the circle. So for this here, it's asking for angle CBD. So CBD is right here. Your intercepted arc this time is right here. So we will just take half of that arc. So 128, we're going to take half of that. 128 divided by 2 is going to give us 64 degrees. So measure of angle CBD would be 64 degrees. Okay. 12 is going to ask for arc BFC. So BFC is this arc right here. We have a couple ways that we can do this. Now, do we know the angle that goes with that arc? We do not. So we can either find it, or we could find this arc and just subtract it from 360. So that's what I was thinking to do first. The arc over here, the rest of the circle, I would just need to double 59, right? If I do 59 times 2, that's going to give me 118. So that would be this arc over here, BC. Then to get the one they're asking for, BFC, what would I have to do? 360 minus 118. And that would be 242. And that would be my answer. Here's another option for you on that, though. These two angles right here have to add up to 180 degrees. So if I do 180 minus 59, I will get 121 for this angle, and then I can double it to get 242. So you can think about these a couple different ways. Okay, how much more have we got? Is this last one? Okay, exterior intersections. Okay, these are the most difficult. You're going to see the least of these, but you will see them. If secants and or tangents intersect on the exterior of the circle, so they're going to cross outside of the circle. You got two lines and they cross outside of the circle, not on the inside. Then the measure of the angle formed is equal to half the difference of the intercepted arcs. Most things are half except for central angles, which is where they're just the same. Yeah. So now this is different than when they cross the inside of the circle, because it's not half the sum, it's half the difference. This is not your average. Okay. So what we would do here for this, if I have, for example, this arc and this arc, like I do, to find this angle on the outside, I would have to subtract these two numbers. 77 minus 28. That would give me 49. And then I will divide that number by 2. So that will give me 24.5 degrees. So instead of adding and dividing by 2, like we did when they cross on the inside of the circle, we have to subtract and divide by 2. Yeah, so you can. And it's not terribly difficult, but it's difficult to keep them all straight, right? Keep all those rules straight. So, just real quick, let's do 14. This is 114 right here. They did not give us the one we need to know. But they did give us the angle over here that would be like our answer, right? So, if I have 114 minus mystery angle here, and I divide it by 2, it should equal 34, right? So what should 114 minus the mystery angle equal? 68, because basically what we're doing there is we're multiplying both sides by 2. But if we double that angle, that's what this should equal. So if I've got 114 minus mystery angle equals 68, well, I could just do 114 minus 68, 47, 6, and I'll get 46 right here. And you can check yourself to make sure that you're right there. Do 114 minus 46 divided by 2, make sure you get 34. We don't have time to do this one really, but how would I find F? Actually, we might. The major arc at FG there, I didn't put a point here. I have to do 360 minus 109, and that would give me 259. And then I'd do 259 minus 109 divided by 2 for that to get my angle. And we are out of time. All right, so you guys have a worksheet for this.